Karnataka 2025 aspirants, welcome to the first class of KCET Masterstroke series. Yes, so today we are going to discuss the one shot of haloalkenes and haloarenes. Okay, so this is going to be the first organic chapter, okay, where I'll be discussing all the concepts. I'll be covering all the concepts. So you need to sit with a notebook and a pen and you need to note down all the important things. Okay, and please quickly share this video with all your friends so that they can also watch this and they can also prepare. Okay, so this is going to be something very effective series, very effective lecture to complete this chapter. So do not miss this and watch till the end. Okay, so in this class we are going to cover all the chemical reactions, physical properties, chemical properties, preparation methods, everything will be covered in detail. Okay, so yes, so students, let's get started. And yes, please join our WhatsApp channel because you will get all the updates. Subscribe to our channel and like this video if you really find this helpful. Fine. So before studying this chapter, you should be knowing what all contents are there in this, right? So you should be always like studying in parts. So you should know that if I am studying this chapter, there are 4 important parts in this chapter that we need to cover. What is our first part that we have to cover? That is your classification, nomenclature and the nature of CX bond. Classification, nomenclature and nature of CX bond. Okay. Next, what we need to understand here we have is preparation of haloalkenes, preparation of haloarenes, and we have physical properties. Okay, so we'll learn the methods of preparation here, learn the method of preparation of haloarenes and their physical properties. And then we have, that is your chemical properties, which is very important, from where majority of the questions will be asked. And last but not the least, we have is polyhalogen compounds. Okay, so this is again very important chapter, very important part, because from here you can expect very important MCQs from their harmful effects, from the uses, from which reaction these are being prepared. So I'll be telling you in point wise. You can just make a note of this and revise them. Okay, so all of you should prepare your short notes with me. So in the first half of your short note, these things should be there so that you have a clear picture of this chapter. If I'm going to study this chapter, what all things I should be studying, or what are the parts of this particular chapter. Okay, so this picture is very important. So moving towards the first one, that is classification. Okay, I'll also be telling you the KCET weightage. So you can see this is year wise weightage, 3 questions, 2 questions, 3 to 4 questions you can easily expect. But this year, as the syllabus is reduced, we can expect even higher number of questions. I can say 4 to 5 questions you can easily expect from this particular chapter. Okay, so high weightage topic cannot be ignored. Fine, we'll go to first classification. What is the basis of classification? One classification is on the number of halogen atoms. Halogen means what? All the elements that belongs to group number 17. Okay, that is fluorine, chlorine, bromine and iodine. If you have any alkyl group and it is attached to these halogens, then we call it what? We call it haloalkanes, right? So number of halogen atoms, on the basis of that we have classification. Then sp3-CX bond means what? You see, this carbon is there and this is this halogen, right? So what is the hybridization of this carbon? On that also we have classification. Then we have sp2-CX bond. So see, if this carbon is sp3 hybridized, if this particular carbon is sp3 hybridized, then what we can have in that? We can have alkyl halides, allylic halides and benzylic halides. And if this carbon is sp2 hybridized, then what all things can be possible? Vinylic and arylic. I will explain all these terms, do not worry. Okay, so first moving to the number of halogen atoms. So if there is only one halogen atom, we'll call it mono. If 2 halogen atoms are there, di. If 3 halogen atoms are there, tri. Okay, similarly if to the aromatic ring, okay, if there is 1 halogen atom, then it is called mono. To the aromatic ring, if we have 2 halogen atoms, then dihalo. Then to the aromatic ring, if we have 3 halogen atoms, then it is trihaloarenes, right? All of you will be knowing this very simple thing. Next we have sp3-CX bond. Okay, so first one is your alkyl halides. Like normally if you have this type of group, so you see, if it is sp3 carbon, okay, so first one, see, very carefully understand, you have the carbon to which the X is attached. That carbon is an sp3 carbon. Means what? That carbon will have 4 sigma bonds. See, suppose this carbon is there, to this X is attached, then this will have 3 sigma bonds. Okay, this one is there, and then we have this 3 sigma bonds. That is called sp3 hybridized carbon. Now this sp3 hybridized carbon can be of 3 types, that is primary, secondary and tertiary. How will you know that? See, the carbon which contains the X group, if this is attached to only one more carbon, okay, here it is H, here it is H, then this is called primary. Okay, if the carbon containing the halogen group is attached to 2 carbons, means this one is also carbon, this carbon is containing the halogen, it is attached to 2 carbons, then it is called secondary. Similarly, if the carbon containing the halogen is attached to 3 carbon, here carbon, here carbon and here carbon, this is tertiary. So this particular sp3 carbon to which the X can be attached will now can be either primary, secondary or tertiary based on what other bonds are there. Clear? This is clear, first one. Okay, next coming to allylic halides. Now what is allylic halides? See, this is allylic halides where you have this carbon which is having this halogen, but this carbon is attached to another carbon which is having a double bond. Then we call this type of halides are allylic halides. Okay, carbon next to the double bonded carbon is called as allylic carbon. Next we have benzylic halides. So you can see here benzylic halides. So this is also very similar to this one. You can see here carbon which contains the X group. Okay, this carbon which contains the X group should be attached to a carbon of the benzene ring. Okay, then it is called benzylic carbon. Okay, or benzylic halides. Now moving to carbon having the X is attached to an sp2 carbon, means you have X and that is attached to carbon which is having sp2 hybridization. Okay, so now this type is called as vinylic halides. What do you mean by here vinylic halides? So you can see this X, okay, is attached to this CH2 carbon, CH2 double bonded carbon, right? So this is called as vinylic carbon. Similarly, you have this double bond, okay, this carbon is attached to X and this carbon is a double bonded carbon or sp2 hybridized carbon, then we call it as vinylic carbon. There is one more thing, aryl halides, where the X is directly attached to the benzene ring. Okay, so in sp2 types we have 2 types, one is vinylic, one is arylic. So vinylic is generally in aliphatic things and arylic is in the aromatic rings. Okay, so basically you can see the same thing, X is attached to sp2 carbon directly here, X is attached to sp2 carbon here, it is also attached here, but this is an aromatic ring, so we will call it as aryl halides. Okay, now moving to next part, that is nomenclature. So nomenclature is very simple, the name will end with, like if any what I'll say halogen is there, so you have to mention the position, halogen name and the parent name of the chain. Okay, so as you can see here, but what is important or what is tricky here is the common name. This is very important. So if we have 2-chlorobutane, so that is actually secondary butyl chloride. How do we get this name? See, it is 2-chlorobutane, but you see this carbon is attached to 2 other carbon, so this is a secondary carbon, so that is why it is called sec butyl chloride. Okay, similarly if you have a structure like this, okay, 3 carbons are attached, CH3 CH3 CH3, then you have CH2 and Br. This is a neopentyl group, so we call neopentyl bromide. Okay, then if you have like this, directly like this, okay, so this is a tertiary group, so this is called tert butyl bromide. Next if you see directly, it is like this, this is vinyl group, right? So vinyl chloride. If you have allyl group, allyl chloride. Next you have orthochlorotoluene, benzyl chloride, methylene chloride. So this is important when you have 2 halogen groups. So on the same carbon 2 halogen groups, it is 1,1-dichloromethane, or you can say the common name is methylene chloride. Similarly, CHCl3 is chloroform, CHBr3 is bromoform, CHCl4 is tetrachloride, CH3, CH2, CH2F is N-propyl fluoride. So this is, the nomenclature is very easy and important as well. The common name should be known to you. Now coming to the nature of CX bond, so this is CX bond. We know X is more electronegative, so that is why this will get a delta negative charge and this will get a delta positive charge. Okay, so now what happens, anything, so I can say that this carbon is electrophilic in nature. Now because it is electrophilic, what happens, nucleophile attacks on this carbon and this X goes. So that is why we can say that haloalkanes undergo electrophilic substitution reaction. Undergoes nucleophilic substitution reaction because it is attacked by a nucleophile. Nucleophilic substitution reaction. Right now, why? What is a nucleophile? Electrophilic is something which is electron deficient, right? And nucleophile is something which is electron rich. That is what you should be knowing. So whenever there is an Rx group, you should be always in mind that if something is attacking, it should attack on the R group. Okay, fine. Now moving to the preparation part. So where we are going to study about preparation of haloalkanes, preparation of haloarenes and physical properties. Now here I want to tell you something very important. So you should have one memory like this. If I am talking about preparation of haloalkanes, how many methods are there? So please write it down, like 6 methods are there. This will help you very much to do active recall. Okay, so if you want to revise it, 6 reactions are there, right? So you have to revise, okay, first was from alcohols, second was from alkenes, third was like this. With reagent you have to recall. Okay, so please mention the number after we have discussed. Okay, that is how you have to do revision active recall. Fine. So let us first talk about preparation of haloalkanes. So this table is very, very important. Please all of you mark it. Okay, I think yes, that's all. Okay, so now see. So first of all, basically there are 3 methods of preparation of haloalkanes. First one from alcohols, second one from hydrocarbons. Under hydrocarbons we have from alkanes and from alkenes. Okay, you know the difference between alkanes and alkenes, single bond, double bond. Now under alkenes we have 2 methods, addition of HX and addition of X2, right? Then third one is from halogen exchange method. So here we have 2 methods, that is Finkelstein reaction and Schwartz reaction. Clear? So now can I go back and write down the methods of preparation here? Okay, so first let us discuss the methods of preparation from haloalkanes or from alcohols. Okay, so you can see if alcohol is there, we can use these all reagents to get different types of Rx. So for getting chlorine, I have HCl and ZnCl2. For getting Br, I have NaBr plus H2SO4, and I can get chlorine and bromine using PX3. I can get using even PCl5. But for PX3 and PCl5, please also remember the byproduct. Okay, if it is PX3, it is H3PO3. If it is PCl5, you will get POCl3 plus HCl. Then you have red phosphorus and X2, that is Rx. Then you have SOCl2, that is RCl plus SO2 plus HCl. Okay, so how many methods I got? HCl, ZnCl2, then I got NaBr, H2SO4, PBr3, okay, PBr5, 4 methods I got, then red phosphorus and X2, and then I got SOCl2. This SOCl2 is very important method and it is the most preferred method as well. Why? Because the byproducts produced here are gases. Okay, so under alcohols I got 6 methods. One is HCl, ZnCl2, second one is your NaBr, H2SO4, third PX3, PX5, then you have red phosphorus X2, and lastly you have the SOCl2 methods. Okay, now coming to from alkenes. From alkanes we have only one method, that is free radical mechanism. You have to use like CH3, CH2, CH2, CH3 with chlorine and H nu. That will give you any of the hydrogens can be replaced. Okay, so you can see here we have 3 equivalent hydrogen. This can be replaced or even this can be replaced. Okay, so this is not a preferred method. Not a preferred method. Why? Because we don't get only single product, right? We get a mixture of products and this is not required. We suppose like this is if you want to prepare one thing but you get another thing also, so you have to, your task is double, right? You have to again separate them. So better to find some method where we can directly get one product. Okay, now coming to from alkenes, so there is two methods, one is addition of HX and another is addition of X2. So if you do addition of HX, it follows Markovnikov's rule. Okay, now what is Markovnikov's rule? Markovnikov's rule tells you that the negative part will attach to R. Okay, the negative part will attach to carbon with less hydrogen. Okay, negative part will attach to the carbon with less number of hydrogen. So what is the negative part here? You see H plus and X minus, right? So this X minus is the negative part, so this will attach to the carbon with less number of hydrogen. Okay, that is their addition of HX, and another is addition of X2. So in this case what happens, this 2X are there, right? So this double bond breaks and we get both side X. Okay, this is the product formed here. Okay, here I want to introduce one term, that is vicinal and geminal dihalides. Okay, so what is vicinal? You know a word in literature, vicinity. Vicinity means closer to each other. So if you have two adjacent carbons X group, then we call it vicinal dihalides. And what is geminal? On the same carbon if you have X group, then it is called geminal dihalides. Okay, this is also important thing. Now moving to the next method of preparation, that is your so that is your halogen exchange method. So here we have two methods, one is your Finkelstein reaction, another is a Schwarz reaction. So Finkelstein is for the preparation of iodoalkanes, right? So what is the use? Rx in presence of NaI dry acetone will give you Ri plus NaX. So here you can see how the reaction is happening. See, this is delta minus, this is delta plus, this is delta minus, this is delta plus. Plus minus combined, we got the product. Okay. Similarly, we have here Schwarz reaction for the preparation of fluoroalkanes. So you take Rx and any of the metal fluoride. So you can see 4 metal fluorides that is given: AgF, Hg2F2, COF2 and SbF3. Please remember this. Question can be asked like this, like which of the following metal fluorides cannot be used for Schwarz reaction? Okay, cannot be used. So you know that this 4 can be used. Other than that, if anything else is given, you can correct it. So don't remember only one reagent, remember all the 4 reagents. Okay. So you'll get Rf plus Agx, okay, or whatever metal fluoride you have taken. So with this we are done with the preparation of haloalkanes. So now if I go and see this chart, so I can say that from alcohols I have 6 methods. From alcohols I have 6 methods. Okay. Then from hydrocarbons I have 2 methods. From halogen exchange method I have 2 methods. So total I can say 6, 7, 8, 9, 10 methods are there for the preparation of haloalkanes. Okay. Now moving to the preparation of haloarenes. Yes, so under preparation of haloarenes we have 2 methods, from hydrocarbons and from amines. Okay, so a very small thing, easy for you. So how can we prepare from hydrocarbons? So by electrophilic substitution reaction. Now see why this reaction, why this is electrophilic substitution. See, the benzene ring, okay, has lone pairs of electrons, right? Because of these lone pairs of electrons, the electron density is more. Now because of this, what happens? This benzene ring itself behave as a nucleophile. So it will obviously attack the other electrophiles. So electrophile will be added to it. That is why the name is electrophilic substitution reaction. So what you have to take? You can take any X2 in presence of Fe dark. So you will get like X and X attached at ortho and para group. Why ortho and para group? Because this X has lone pair, it pushes the electrons and the electron density increases at ortho and para position. So that is why substitution will take place at ortho and para position. Okay. Now you can see here we can get chlorine and bromine. Reaction with I2 are reversible in nature. Fluorocompounds are not prepared due to high reactivity of fluorine. Okay. So now what happens if you do with iodine? So that reaction will reverse. So that is why iodine is difficult and fluorocompounds reaction is also difficult because of its high reactivity. So basically easily what we can prepare? Chloro and bromo. Okay. Now moving to the next one from amines, so that is your Sandmeyer reaction. You have to take aniline, okay, then convert it to benzene diazonium chloride, okay, benzene diazonium chloride. Okay, now once this is done, you can use Cu2X2 to get X, that is X can be chlorine or bromine, and Ki to get iodine. Okay, so that is, and byproduct also you should be knowing, that is N2 gas is produced. Okay, so these are the two methods for preparation of haloarenes. Now let's talk about the physical properties. So very easy thing. Melting point depends on two things: mass will be more, melting point will be more, and branching, inversely proportional to branching. If branching is there, melting point will decrease. So for example, if I have butane, okay, I have a formula like C4H10. So we have one compound like this, we have another compound like this, okay, and I can have, yeah, these two compounds I have, right, they are having same molecular masses, but here you see branching is there, so its boiling point will decrease. So this boiling point will be more, okay, this one will be having more boiling point. Density increases with the increase in the number of carbon atoms. Next, solubility. These are generally less soluble in water and they are more soluble in organic solvent, okay, because these are less polar compounds, so that is why solubility is less, and solubility will further decrease with the increase in masses. This is applicable everywhere, so it is not anything specific to haloalkanes and haloarenes. Solubility will always decrease whenever the R group will increase. Remember this one, okay. So yes, physical properties we are done. Now we'll go to chemical reactions. Okay, so under chemical reactions we have, chemical reactions we'll study for haloalkanes, we'll study for haloarenes. In haloalkanes we have nucleophilic substitution reactions, elimination reactions, reactions with metals. In haloarenes we have nucleophilic reactions, electrophilic reactions, and reactions with metals. Okay, so let's go and discuss first the nucleophilic reactions of haloalkanes. So this I have already discussed. Nucleophilic reaction, see, when you have R and X, right, I can say this R is behaving as an electrophile, so nucleophile can come and attack on this one, so that what we will get, RNU. Right. So what are the different types of nucleophile, and when they attack, what are the products formed, that we will discuss under different nucleophiles. And this attack can be of two types, okay, there are two mechanisms on that, or I can better write mechanisms, that also I will discuss. Okay, so moving to different types of nucleophile, this is the list of nucleophile, you should be knowing this table. So if you use NaOH, okay, as a reagent, then what nucleophile it give you, OH minus. So you have this Rx, okay, so remember Rx plus nucleophile gave you RNU, okay. So this nucleophile you have to attach here, so RNU will give you ROH. Similarly, if you do with H2O, it will give you ROH. Similarly, if you do NaOR, that is Na plus and RO minus, so the nucleophile is RO minus, so this one will replace this one and we'll get this electrophile. NaI, that is I minus, will give you Ri. If you take NH3, it will give you RNH2, and if you take R dash NH2, that is a amine, so you will get here. Similarly, this which is important here, KCN and AgCN, this is what you get confused. With KCN we will get RCN, with AgCN we will get RNC. Okay, this is important. Now similarly, KNO2 and AgNO2, with KNO2 you will get RONO, that is what, alkyl nitrite, but with AgNO2 you will get RNO2, that is nitroalkane. Okay, this difference you should be knowing. Next, what we have, with lithium aluminium hydride you will get RH, okay, with R minus M plus you will get RR, that is your alkane group. With RCOOAg you will get RCOO minus, so you will get here an ester. Okay, okay, now talking about the types, so let me explain here, one second. Okay, so now these types are of two types, okay, one is your SN1 mechanism, one is your SN2 2 mechanism. Understand very carefully. Now what is our basically the task is, you have one Rx, a nucleophile has to attack on this one, and this RNU has to form. So this X is replaced with NU, okay. So that is why this is called a nucleophilic substitution reaction. But this reaction, as I said, can occur in 2 different ways. What is the first way? SN1 mechanism. What happens in this one? So remember, it always remember SN1, it takes in 2 steps, okay, and SN2 take place in 1 step, okay. Very, very important thing. Now what happens, see, if you have, for example, CH3, 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 Cl, okay. Now in this, the first step is what? There is a formation of an intermediate called as carbocation. Means what happened? In the first step, this Rx bond breaks, okay. So what I'll get? If this bond breaks, here I'll get a positive charge. So that is called formation of carbocation. Okay, this is the carbocation that is formed in this reaction. Now there is step number 2, that is attack of nucleophile. Now here what will happen? Suppose I am taking like OH minus as a nucleophile. So what will happen? CH3 whole 3 C plus OH minus is there, right? This OH minus this is now when a carbocation is formed, okay, it is a planar molecule. What do you mean by planar molecule? This, all the 4 carbons are in one plane, okay. Here there is carbon, another 3 carbons are in one plane. So what is this OH minus? This is one plane. This OH minus can attack from the top and can also attack from the bottom, okay. Attack from this side also, attack from on this side also. Now see, if it is attacking, so which side this, suppose Cl was there. So let me assume that Cl was on the top side, okay. Now the Cl is removed, molecule become a planar. So when the Cl was there, molecule was not planar, okay. When Cl was there, this molecule is tetrahedral, okay. It was like this, tetrahedral shape. Once this Cl is removed, okay, it became a planar. Now this OH minus can attack from the same side where there was Cl, or it can also attack from the opposite side when there was no Cl. So if we get 2 types of product here, so let me draw it like this. See, this is from the side where Cl was there, okay, because I have written on this is from this side, and I can also have a product like this where it is from the opposite side. Now if it is from the same side, we call the retention. If it is from the opposite side, we call inversion, okay. So there are 2 possibilities, right? It can attack from this side also, this side also. So that is why what happens, there is 50% probability of this one and 50% probability of this one. So both are formed in 50-50 percentage, okay. This type, so what is this what is this product, what does it do? See, now suppose, let me not take CH3, I'll give you another, like just let me take it like A, B and D groups are attached, okay. So similarly here also I will write A, B and D. Next here I will write same thing, A, one second, yes, A, B and D. Here also I will write the same thing, that is A, B and D. Now what do you find if what is the difference I made if I added A, B, D? See, now to this carbon all the 4 groups are different. So this is a chiral molecule now. What is the property of a chiral molecule? It rotates the plane polarized light, right? So now if you see, what is the difference if OH on this side and if OH is on this side? So this particular compound will rotate the plane polarized light in one direction. It can be clockwise or anti-clockwise. But because this is an opposite compound of this one will rotate it in the opposite direction. Like for example, if this one rotates clockwise, this one will rotate anti-clockwise, okay. So see, suppose this is there, okay, you have this sample, let me show you like this. See, you have this sample, so you have kept this one, what is this molecule, and OH minus you kept it in this container. After some time what will happen, you got, suppose let me name this compound as X and this compound as Y, okay. So after some time X and Y will form in this solution, there is X and Y. Now you passed a plane polarized light through this solution. So what we'll do, see, X is there. First suppose X interacted with this one. X rotated it in clockwise direction, okay, clockwise direction. 50% X is there, suppose 5 molecules are there. So 5 molecules of X rotated in this direction. What will Y do? Y will rotate it back. Clear? So this is plane polarized light. See, plane polarized light was traveling like this. Here the solution came. So when it met X, it rotated like this. After some time it met Y, it rotated like this again. Then it is going again, right? So what exactly this type of mixture is called as? Where there is both type of configuration in equal percentage, this mixture is called as racemic mixture. Okay, so what has happened to the plane polarized light? It went like this, rotated like this, rotated back like this and came back, right? So there is, what can we say here? Is there any change in the configuration of this plane polarized light? No. Why? Because we are getting equal amount of this one. So what you don't know, suppose if I say that there is no X and Y, you are unknown person, what will you think? That this light came like this and then it went like this, right, straight way. So what will be your thought? That this solution is optically inactive. Why this solution is optically inactive? Because there is no rotation in the plane polarized light. The initial light and the final light is exactly same. So that means that this solution is optically inactive, because if it would have been optically active, it would have rotated the plane polarized light, okay? But actually they are optically active compounds. You see all the 4 groups are different, right? They are optically active, but they are in equal proportion. So you know, 2 opposite charges equal in magnitude will cancel each other. The same thing happens here. So we can say that this final product which is formed here is a racemic mixture, okay? This is called as racemic mixture and it is optically inactive, okay? But it contains optically active compounds, but because they are present in equal amount and they behave oppositely, they together cancel out each other's effect and they are called as optically inactive. Clear? Okay, next moving to the second mechanism, that is SN2. Okay, here very simple mechanism happens. You have Rx, okay, Nu comes. Okay, here a Rx bond doesn't break initially. What happens here? This Nu has to attack from the opposite side only. Okay, if it attacks from the opposite side, what will happen? We get a transition state. Okay, now once this transition state is formed, then this bond will form and this bond will break. Clear? So what we are observing, this Nu is attacked or attached to the opposite side of X. Why? Because here there is no carbocation formed. So R is here, this side X is there. This part is bulky, right? Or it doesn't have space to attack from this side. So it wants a free space and attacks from the opposite side. That's what. So here, because there is no formation of carbocation, it completely depends on the steric hindrance. What do you mean by this? This rate of this reaction depends how spacious the molecule is, or how less hindered, less obstructions are there in the molecule. So that is why the order here is primary degree, secondary degree and then tertiary degree. But in SN1 there is a formation of carbocation, right? So that is why here the order is tertiary, secondary and primary, because tertiary carbocations are more stable. Okay, fine. So this is a differentiate between SN1 and SN2. Any question can be asked, so let us quickly revise. It is a unimolecular reaction. What do you mean by unimolecular reaction? Unimolecular reaction means at the time of reaction, the rate of the reaction depends only on one molecule. Yes, definitely, because in SN1 what is the first step? Rx is there, R goes out, okay, we form this one. So it only depends on this Rx concentration, so it is a unimolecular reaction. But in case of SN2 we have Rx plus Nu, it depends on both this concentration, so it is bimolecular. Now SN1 reaction follows first order kinetics, it follows second order kinetics. Mechanism here involves 2 steps. One is the formation of carbocation, second is the attack of the nucleophile, and it follows only one step. Rate of the reaction depends on the concentration of substrate only. Rate of the reaction depends on concentration of both substrate and nucleophile. Now carbocation is formed here, no carbocation is formed. There is no partial bond formed with the carbon using the reaction. So which is the partial bond? It is talking about this partial bond. Okay. In SN1 no such partial bond is formed, here the partial bond is formed. Next you have nucleophile attacks the carbocation from both sides, although backside attack dominates. It can attack from both the sides, but here it is always attacking from backside. Next, partially racemized product is formed. I told you what is racemic mixture. Here only inverted product will form. Okay. Next, it is favored by mild nucleophile, it is favored by strong nucleophile. Here the solvents are of high polarity, here the solvents are of low polarity. Rearrangement of product takes place. Now why there will be rearrangement? Because there is a carbocation generated. Here there is no carbocation, so no possibility of rearrangement. Here what is the order in 12th? The order of what I'll say, SN1 is 3 degree, 2 degree and 1 degree, and the order of SN2 is 1 degree, 2 degree and 3 degree. Okay, that's all. Fine. Now moving to elimination reaction. So we are discussing the reactions of haloalkanes, right? We haven't done the haloarenes. So under haloalkanes, we discuss nucleophilic substitution reaction. What are the different nucleophiles? Then we discuss the mechanism. There are two types of mechanism, SN1 and SN2. Now we are going to the second type of reactions of haloalkanes, that is your elimination reaction. So always remember, in elimination reaction the product formed is always an alkene group. Okay. So here what happens, what is eliminated? See, this is a carbon which contains the X group. Okay. So this is the alpha carbon, this is the beta carbon. So the hydrogen of the beta carbon and the X of the alpha carbon are removed. So when these two carbons are losing two bonds, this bond has to be satisfied. So that is why a double bond is formed here. So this B minus takes this H and this X minus is formed. So X is the living group here. Okay. So you can see one example. So okay, something here is very important we need to discuss, that is your Zaitsev rule. Zaitsev rule. Most of you will be knowing it, but let me take you this example, 2-bromopentane. Okay. So we have, suppose, or let me take a smaller example, that is 2-bromobutane. Okay. Now what is the reagent for this one? You have to use alcoholic KOH. Okay. So here there is one H, here there is one H. Now if I use this one as alcoholic KOH, then what will happen? See, either this HBr can be removed because this is alpha carbon, right? This is also beta carbon, this is also beta carbon, this is also beta hydrogen, this is also beta hydrogen. Either this one can be removed or this one can be removed. So what all products I can get? We can get like, this is one product plus this is another product. We can get these two products, right? Now which product will be the major product here? So see here, in this case, okay, always remember more substituted alkene is the major product. Now how will you find out which is the more substituted product? See, very simple trick I'll tell you. You have this carbon-carbon double bond, make a box around it. Here also let me make a box around it. Now you have to see to this carbon-carbon double bond how many carbons are attached directly. Okay, so it is like this. So I will say that this is one carbon and this is one carbon, two carbons are attached here. Here let me take a box. Here this is one carbon only. So I can say that this side it is H, right? So I can say that to this double bond carbon there is only one carbon is attached. Here two carbons are attached, here one carbon is attached. So which is a more substituted alkene? The 2 carbon one is a more substituted alkene. So that is why the major product formed will be this one and not this one. Okay. So similarly you can see we have 2-bromopentane. Okay. If I have 2-bromopentane, I have this Br and H possibility also, this H and Br possibility is also there. So double bond can form here and double bond can form here. So if I see this double bond, I have 2 carbons attached beside it. You do not count this one, only the direct carbons. And here you can see there is only one carbon is attached. So this is 81% product, this is 19% product. So this rule that whenever there is dehydrohallucination, this reaction is called as dehydrohallucination. dehydrohalogenation, because you are removing one hydrogen and one halogen group. So whenever there is dehydrohalogenation, the major product formed will be a more substituted alkene. Okay, that is simply is what Zedzev rule tells you. Okay, next we will move towards reduction with reaction with metals. Okay, so this is very simple, just you have to understand plus minus. See, metals are always positive. Okay, so what happens, this is delta minus, this is delta plus. So whenever you give one Mg, this Mg comes and gets inserted here. So we get CH3 CH2 MgBr, and this is nothing but Grignard reagent. Okay, next if you have Rx and Na, this is a name reaction, Wurtz reaction. So here what happens, see, Na, okay, Na reacts with this X and we get RR, means hydrocarbon is formed, double the number of R. Suppose you have taken here ethane, you will get ethane, means butane you will get. If you have taken propane, propane 3 hexane you will get. Okay, so that is your Wurtz reaction. Okay, next we'll move to the reactions of haloarenes. Okay, so generally what happens, haloarenes, I have already shown you, this is haloarene, right? Okay, so this X donates the electrons to the ring, even the benzene has double bond in it. Okay, so that is why the haloarene ring itself, it is electron rich. Okay, so if it is electron rich, then I can say that it is nucleophilic in nature. Okay, so if it is already a nucleophile, will it react with another nucleophile? No, right? It is very difficult. So that is why haloarenes do not react with nucleophiles easily. Okay, so that is why less reactive towards a nucleophile. The first thing is resonance effect. Due to this resonance effect, what happens? The ring is already electron rich. Next, you have difference in the hybridization of carbon atom. Now, if you see this carbon atom, okay, this is an sp2 carbon atom, and this X bond, this bond is very strong. Okay, so that is why it is not very easy that you bring someone from external, this external will come, okay, you come and this I will replace this X. That will not happen. Now see, very simple thing, understand this one clearly. Okay, see, suppose I have like this. Okay, this is an sp3 carbon. Okay, this bond between one sp3 carbon and X is not good. Okay, just like relation between your friend and your classmates or your best friend's another friend. Okay, so the relation is like this. So this is your friend, this is you, this is your friend's best friend or friends. Okay, friends. So this bond is not very strong. You and your friend bond is strong. You and your friend's friend bond is weak, right? So that is like this. So what will happen if nucleophile will come? Okay, nucleophile is what? Nucleophile is something external person came, then this, it can easily break this bond. Why? Because these two bonds are not very strong. But in case of sp2 hybridized, okay, sp2 hybridized, I'll say like this, this is you and this is your best friend. Will you let your best friend go for any other person coming? No, right? The same thing happens. So when the nucleophile comes, this bond, it cannot break. Why? Because this is sp2 carbon and this is the sp2 and best friend bond is very strong, so we cannot replace it easily. Okay, so that is the thing why, that is because of hybridization, this bond is very strong. Next, even if this X goes out, somehow you and best friend quarreled and you go, after your best friend and you break up, I can say, okay, friendship breakup is happening, we generally are very depressed, right? So this carbocation which is formed will be very depressed and cannot sustain, cannot survive. So that is why the best friend cannot live here. Okay, so that is why the reactivity of the haloarenes towards a nucleophile is very low. Okay, but still it can react under very extreme conditions. So you can see here that generally at 623 Kelvin and 300 atm at very high temperature and high pressure, Okay, high pressure you have given to somebody, has given you, no, you have to do breakup with your best friend, some that much high pressure has come, then only that reaction will happen. Otherwise, how can this reaction will happen? If you, okay, you and your best friend are there, but if you have got many other good friends, okay, with time when we go college we generally forget our school friends, right? Why? Because we have got so many friends with us who provide us the same comfort. Okay, so when we get so many friends, at that time you can leave this X, right? So same thing, you see, when this Cl has got this NO2 group, okay, when so many NO2 groups come here, reaction is possible. Okay, and reaction can possible without even very low temperature also, the reaction can be possible. But exactly what is happening according to chemistry? See, these are NO2 groups, these are electron withdrawing groups. So if they are electron withdrawing groups, what will happen? They will pull the electron towards itself, right? If they pull the electron towards itself, then what I can say is this ring is becoming electron deficient. If it is becoming electron deficient, the OH minus, okay, which is a nucleophile, it can attack very easily here. Okay, so that is why when NO2 group is added, the reaction can happen even at the warm temperature. Okay, so next, moving to the electrophilic substitution reactions of these haloarenes. So if it is not showing nucleophilic reaction, it will show electrophilic substitution reaction. Why? Because this ring is itself nucleophilic, it can attack other electrophiles. So if you want to add chlorine, okay, Cl2 and FeCl3, this is called as halogenation reaction, XCl, XCl. Next, if you want nitration, concentrated HNO3 and concentrated H2SO4. So this is XNO2 and XNO2. Sulfonation, concentrated H2SO4 and heat. You will get SO3H, SO3H added at ortho and para position. Okay. Next, if you do acylation, okay, Friedel-Crafts acylation, CH3COCl and AlCl3. So it is COCH3, COCH3 will be added. Friedel-Crafts alkylation, that is CH3Cl, AlCl3. So that is CH3CH3. Okay. Now a question arises, why there is no substitution at the meta position. So now if I just draw the, one second, yes, okay, just before doing that, if I just show you the X as lone pair, it gives its electron, this electron shifts here. So if I just draw the resonating structures, okay, I am getting negative charge on this one. Now this one will come here, this one will come here. So what I will get? Like this. Okay. Then if we get like this, one second, let us draw it. Yes. So now if you see these things where we are getting negative charge on ortho and para position, right? So if an electrophile will come to those positions where the electron density is more, right? So you can see that electron density is more at ortho and para position. So that is why all the substitution that we have seen, whether it is halogenation, nitration, sulfonation, Friedel-Crafts acylation, alkylation, everything takes place on the ortho and para position only. Okay. Fine, that was there here. Now let us see the polyhalogen compounds, what all compounds we are going to study. So we are going to study about dichloromethane, trichloromethane. So this is CH2Cl2, that is methylene chloride. This is trichloromethane, okay, that is your chloroform. This is iodoform. Okay, next we have tetrachloromethane, CCl4. Then we have freons, this is something important, DDT is also important, okay, we will see them in detail. So first of all, dichloromethane, you should be knowing certain uses of them, okay, so it can be used as a paint remover, propellant, okay, then nothing much is there, but you should know the symptoms. What if it is harmful effect is there, what if it is lower level, then we may get hearing and vision if you are exposed to this chemical in a lower concentration. But if you are exposed to this at a higher concentration, you will feel dizziness, nausea, tingling and numbness in the fingers. If there is direct skin contact, it can also cause burning, and if direct eye contact can also burn the cornea. So a very reactive and a very harmful chemical, so you should handle it carefully. Next, if we go to trichloromethane, so from here this question is very important. Every time it is asked, these all things you can read, but from here no question is asked. From where question is asked is, it slowly gets converted to a poisonous gas, that is COCl2, called as phosgen. Okay, what is the COCl2 called as? Carbonyl chloride. Okay, you will get question from this one, and this reaction is also important. So what happens when CHCl3 is exposed to oxygen in presence of light? You get COCl2 and HCl. So that is why this is not stored directly, it is stored in darkness, so that it doesn't get this light to get reacted. Okay, this gas is important. Next, coming to iodomethane. So what is, triiodomethane, that is your iodoform CHI3. Okay, so it is used as an antiseptic, but here this part is also a question, potential question. The antiseptic property are due to the liberation of free iodine and not due to iodoform itself. Okay, so when CHI3 reacts, okay, it gives you free iodine, and this free iodine has this antiseptic property, not the iodoform directly. Okay, so indirectly it is used in antiseptic property. Next, we have tetrachloromethane, CCl4. So here also you should be knowing the harmful effects. So it is used in the depletion of, environment, depletion of ozone layer, then skin contact, higher levels, lower levels, what happens? You can read this. Okay, I'll come to this is, which is very important, from where questions have been asked regularly. What are freons? They are chlorofluorocarbon compounds of methane and ethane are collectively known as freons. Okay, means in a methane you have 4 hydrogen, right? So when these hydrogens are replaced with chlorine and fluorines, we call them as freons. There is one specific compound, that is freon 12, CH2Cl2F2. It is prepared by Swartz reaction. Please remember this one. This can be asked as a question, very potential question. Next, where it is used, these all things you can read. Freons are definitely a main component for the radical chain, and which leads to your ozone depletion. Okay, okay, that's there. Next, lastly, coming to DDT. Okay, so DDT formula, you should be the formula of DDT is important. Okay, but not many times it is asked directly, but yes, you can remember the formula of DDT. Next, DDT is not metabolized but very rapidly by animals. Instead, it is deposited and stored in the fatty tissues. Okay, so when it is consumed by mistake by animals and all, it is stored in their body. If ingestion continues as a steady rate, DDT builds up within the animal over time. Okay, so that is why DDT was banned in many countries and now it is not used. Okay, earlier it was used as an insecticide. Okay, so that's all about this chapter, students. So what basically you have to study in this chapter is your haloalkanes preparation, haloarenes preparation and the reactions. Okay, so that is what you have to focus, and SN1, SN2 and your freon 12 and physical properties, melting point and boiling point and solubility. Okay, so yes, with this I will be ending this lecture, and if you have any doubt in any of these concepts, please comment down, and remember these videos are going to be very helpful, so please like, share and subscribe. Share with all your friends who are preparing for KCET, who are preparing for COMEDK, who are preparing for PU2, so please share with them. Okay, this will definitely help you, and I can promise you that this series will be very effective for your preparation. And tomorrow we will be solving questions from haloalkanes and haloarenes. So all of you know what you have to do. You have to be ready at 11 AM and I'll be coming up with some best questions, with some tricky, difficult as well as some moderate level and easy questions for all of you. So whatever, so there will be no PYQs because we have already solved PYQs, right? Same question you don't have to solve again and again, but yes, I will bring little tricky like little higher level questions as well as little easy level questions. All types of questions will be covered in tomorrow's class, so make sure that all of you are available. Okay, that's all students. Please share the video, please subscribe the channel, and thank you for watching, and see you soon in the next class. Till then, please remember, exams are very near and we are going to prepare really hard. Our goal is top 1000 rank and we will achieve it, right? So those students who have understood the concepts and are in the journey with me to get top 1000 rank, please put a comment in the comment section. Thank you and see you soon again in the next episode.